Welcome back to a question a day. Okay, and the question is, we have a figure 4 here. Okay, we have a cupboard. So figure 4 shows a 40 kilogram cupboard is being pulled up along a rough inclined plane, so 30 degrees to the horizontal by a light rope. Okay, the cupboard moved at a constant velocity, and the coefficient of kinetic friction between the cupboard and the inclined plane is 0.5 meter. So we take out the information we have in this question. So we have mass, we have angle here, and we have mu. And one more thing, the hidden information is from the word constant velocity, which means that our acceleration is equal to 0. So our first question is to draw the free body diagram of the cupboard. And second question is to determine the magnitude of frictional force and the tension acting on the cupboard. So let us solve A first. So we need to draw the free body diagram. So before we draw the free body diagram, we make sure that we know what type of forces acted on the cupboard. First we have normal, and of course we have tension, T, and weight, it is always directed downward, and also we have friction. Okay, so friction, because in the question it says that we have the coefficient of kinetic friction, which means that in this case we have friction. So for the free body diagram, we make sure our block is becoming a dot. We make sure all the tails of the forces must be at the center. So we have normal, weight, downward, frictional force, and also tension. Okay, so this is our free body diagram. And to solve B, okay, we want to find the frictional force. In this case, our cupboard is moving, so we have Fk, okay, and also we want to find tension. Okay, so class, we know that our frictional force, the equation is mu n. We have the information of mu from the question, but we don't have the information of normal, which means that we need to find normal. If we refer our free body diagram once again, okay, our normal is in y-axis. So apart from normal, you also have your y component of weight. Okay, so we have here wy. Okay, and also we resolve weight, we can also have ws. So to find normal, we are using the information for y-axis. So summation of fy is equal to 0. So we have normal minus wy is equal to 0. And normal is equal to, so your wy is equal to, so our angle here is 30 degrees, which means that w cos theta. So we substitute the values, so it's equal to mg cos theta. Okay, so our frictional force is equal to mu n, and n is equal to times mg cos theta. So we substitute all the values. 0.5 times mass is 40, 9.81 times cos 30. Okay, so you will get your frictional force as 169.91 Newton. Okay, so that is for frictional force. So we want to find tension. So T. Okay, so if we refer once again, if we refer our free body diagram here, okay, so our tension class, okay, our tension is in x-axis, meaning that we are going to solve this question using information in x-axis. Summation of fx is equal to ma, and please remember that we have constant velocity, which means a is equal to 0. So our equation is equal to T minus frictional force minus ws is equal to 0. Our direction of motion is following the direction of tension. So that's why T is positive, F is negative, ws is negative. Okay, so remember we want to find tension. So tension is equal to frictional force plus ws. So ws is mg sine theta. So we already have friction from the previous equation, 169.91 plus our mass is 49.81 sine 30, and finally it will give us tension is equal to 366.11 Newton. Please always have a double check on your calculation and make sure your unit is correct.